I'm Dr. Bino. In digital signal processing subject, the fourth topic is a fast Fourier transform. Simply, it is represented by FFT. FFT is an efficient algorithm used to compute the discrete Fourier transform and its inverse. DFT requires n square operation, but FFT reduces the computation to n log n to the base 2. Why FFT is needed? The DFT formula is capital X of k is equal to summation of n is equal to 0 to capital N minus 1 x of n w n to the base nk, where w n is equal to e to the power of minus j2 pi by n. Here the computation complexity is order of n square. For large amount of n, example some 1024 as well as 4096, DFT becomes very slow. FFT reduces their computational complexity to order of n log n because of the computation is faster. What is the basic idea behind the FFT? Is divide and conquer concept. FFT splits a sequence into even indexed samples and odd indexed samples. That is, x of k is equal to even k plus w of n k order of k, where e of k is equal to dft of even index samples, o of k is equal to dft of odd index samples, w to the base n k is equal to Twiddle factor. Types of FFT algorithms. Radix to FFT algorithm is the most common FFT algorithm. Works when n is equal to 2 to the power m, that is 128 to 56,024, etc. It consists of two forms, decimation in time and decimation in frequency. The second one is radix 4 FFT, faster than radix 2, but requires n is equal to 4 to the power of m. The third one is mixed radix FFT, used when n is not a power of 2, that is 300, 500, etc. What is meant by butterfly diagram? The basic computation block of FFT is the butterfly. A butterfly performs two operations. X1 is equal to A plus WB, X2 is equal to A minus WB. Why the name butterfly? During FFT computation, two wires are used, one split apart, cross each other, and join again through addition, subtraction, and Twiddle multiplication. This shape resembles the wings of a butterfly with crossing points in the middle acting like the body. This crossing of branches form left side wings inputting NB, right side wings output X1 and X2, center body Twiddle multiplication. It visually looks like a butterfly spreading its wings. DAT effective, that is decimation time. Input sequence is split time domain. Output is in natural order, but input requires bit reversal. What is meant by DAF? F of decimation in frequency. Output sequence is split, that is frequency domain. Input is in natural order, but output requires bit reversal. What are the applications of FFT? FFT is normally used in digital signal processing, spectrum analysis, OFDM, image processing, speech and audio processing, radar and sonar, biomedical signals like ECG and EKG. How we can compute DFT and DFT? DFT is simply a frequency domain representation of the original input sequence. The DFT pair equation is represented in this slide. Computation of DFT using FFT algorithm. FFT is a highly efficient procedure for computing the DFT of the finite series and requires less number of computations than that of direct evaluation of DFT. By means using DFT transform pair, I had the Twiddle factor Wn is equal to the power of minus 2 pi by capital N. What is radix to FFT? Number of output points n can be expressed as the power of 2, that is n is equal to the power of m n is integer. Then the algorithm is known as radix algorithm. Advantages of FFT over TFT. FFT is the algorithm used to compute fast, computationally efficient than direct computation of PFT. Exploit periodicity and symmetry property of PFT. It makes use of periodicity and symmetry properties of the factor gives the DFT time. Radix to DATF of the algorithm. The endpoint DFT of a sequence X of n converts the time domain endpoint sequence X of n into frequency domain endpoint sequence X of n. In DAT, the X of n decimated and smaller points DFTs are performed. The result of smaller points are combined to get the result of endpoint DFT. Here, the endpoint DFT can be realized from two number of n by 2 points DFTs, and n by 2 point DFT can be realized from two number of n by 4 point DFTs, and so on. Radix to DITF of the algorithm, the normal order as well as the bit reversal order used in the DITF is represented here. The radix to DITF of the algorithm's block diagram is represented in this diagram. The butterfly diagram for 8-point radix to DITF of the algorithm is represented in the diagram. The calculation for the twin factor values so represented in the slide. It is the twin factors are calculated in such a way that Wn is equal to e to the power of minus 8 2 by k by n. Likewise, we can calculate w to the base 2 power 0, w to the base 4 power 1, w to the base 8 power 2. Likewise, we can calculate the value. Radix to DIF f of the algorithm. In DIF algorithm, the frequency domain sequence x of k is designated. In this algorithm, endpoint time domain sequence is converted to two number of n by 2 point sequence. Then each n by 2 point sequence is converted into two number of n by 4 point sequence. This process is continued until n by 2 number of 2 point sequences is obtained. In DIF FFT, the input is normal order, the output is bit reversal. The butterfly diagram for the 8-point radix to DIF FFT algorithm is the structure is represented in this manner. Radix to DIF FFT algorithm. Differences between DIT and the DIF algorithm. DIT FFT time domain sequence is decimated. DIF FFT frequency domain sequence is decimated. In DIT FFT, input should be in bit reversed order, output will be in normal order. But in DIF FFT, input should be in normal order, output will be in bit reversed order. In DIT FFT, complex multiplication takes place before the addition subtraction operation. In DIF FFT, complex multiplication takes place after the addition subtraction operation. Thank you.